Welcome to the program on rotary compressors. We shall be discussing about screw compressor, lobe compressor and vane compressors. We will be discussing working principles and types, their uses, components and their function, bearing and lubrication, flow control, glands, sealing systems, failures and reasons and remedy, and troubleshootings. First, let us see what happens to the air as the air or gas when it is compressed. See, the gas law says PV is equal to RT, that is pressure into velocity is equal to universal gas constant R into the temperature. Keeping the combination law in the mind, when the air is compressed, the pressure and the temperature of air increases as the volume of the space containing air reduces. This is called adiabatic compression. It means that when the gas or air is compressed, its temperature increases. And rotary compressors, they got their name from the rotating motion of the transfer element. It compresses the gases with lobes, screw or sliding vane into the smaller volume. They are positive displacement compressors, means the flow is constant at all discharge pressures. There are three primary types of rotary compressors: rotary screw, single sliding vane compressors and lobe compressors. First, let us talk about the screw compressors, and most of the screw compressors have got two screws rotating in opposite directions. So the rotary vane compressor have got two internal screws that rotate in opposite direction, trapping and compressing air between them. The two screws also generate constant movement as they rotate. This is common type of compressor and it is one of the easiest to take care of. The compressors are typically industrial size and are great for continuous use. So if we see on the right hand bottom, we can see a video where there two screws are rotating in the opposite direction. The gas is coming in from the right hand side and it is pushed and it is coming out from the left hand side. If we see how the process happened, we will be able to see on the bottom left. So here there are two screws. When the screw turns, it creates some vacuum and the gas comes in through the inlet and then it is passing through through the gap between the screw and the body and it travels towards right, and finally the air is forced out from the outlet. So if we see on the right hand side, there are two screws. This screw is called mare screw because this is connected to the motor, and another screw is called female rotor. This is the suction flange. So gas comes from here, is got out from the bottom. There are angular contact bearing to take care of the axial load. There are bearings to radial bearings are also provided. These are here, the radial bearings are provided here. And then there is a slide control valve to control the flow through the compression. Now here we can see some more components. You see, this is the male rotor on the top. At the bottom we have got female rotor. These are bearings are located here. Seals are here and seals are here also, and bearings are also on the both sides. This is the coupling, and here what you see here is a wear plate because the gas is being pushed from left hand side to right hand side. So the rotor will try to move from right to left, and if the thrust bearing is not able to control that, the there is a wear plate provided. The rotor will rub the wear, it will not rub the housing, and housing will not get damaged. Here in this drawing we can see the timing gear. These are the timing gear which is rotating the two shafts in opposite direction. These are the bearings area and these are the seals, and there is a cooling jacket provided. If the temperature goes up, for that there is a cooling jacket provided through which the water is circulated to keep the compressor cool. In this, here we are able to see, here we are able to see a compressor which is rotating. On the left hand side we are able to see the two timing gears, and as this is, as this one is it is double flow, means it is, there is, the gas is entering from left hand side and then it is flowing towards the right side. It is also entering from right side, flowing to the left, and then finally it is going out. Now here we are able to see that how the lubricating oil flows through the screw compression. Here on the top we are able to see the compressor, and air enters from here. Lubrication is used mostly for the air compression. So air enters from here and then it goes out from here. Now there is a lube oil pump here which is now pressurizing the lube oil, which comes through a thermal bypass valve. The purpose of this valve is to maintain the oil temperature at the outlet of the cooler. If the oil temperature starts going down, this valve will, it is a three-way valve, so it will bypass some of the lube oil to the cooler so that the temperature is maintained. Then the oil passes to the filter to filter the debris. Then it goes to a manifold, and from there three lines are going. One line we will call injection line, where the oil is injected to the compressor, and the two other lines are going to the inlet and outlet bearing of the compressors. Then the lubrication and air both are coming to a air lube oil separator. Here the it is separated, oil goes again to the pump and air goes out. If some oil vapors are there, through this lubricant expunging line it will go to the compression. Now here we will be able to see that how screws can be fixed in a screw compression. So let us see. First is, we have only take it out from the packing, the screws when you need it, take it, and then slowly you insert first the male rotor, and you may have to slightly rotate it when you are taking it in, and like that you push it up to the extent that the surface is fully matched with the body surface. After that, you will take out the second rotor, and then after taking out the second rotor, you have to push it inside on the next opening, and you will have to slightly rotate it so that it is able to go inside fully. When it goes inside fully, you see the two are matches and the rotor insertion is complete. Now let us see that there is something very dangerous inside the compressors, which has got a spring loaded flow control valves. So these are high pressure valves, and if carelessly, unknowingly, if cover is removed, there is a chance that it may come and hit the technician. You see the springs are here. This is the sliding valve. This is inlet outlet. This is the sliding valve. So if he opens it suddenly, the spring will push everything out and he get injured. So the technician needs to take care of this. Now let us see the problems in the screw compressors. So there may be leakage from the joint, from the seal, there may be bearing failure, there may be low flow, abnormal noise, vibration, overheating, there may be oil degradation, there may be a wear or failure of the screw, which is shown on the right hand side here. There may be seal leakage, there may be body wear, or there may be wear plate failure. Here there are few drawings shown. The top left is showing you the wear in the body due to the contaminated gas or air coming inside. The bottom one is there is a body wear because when the bearing has failed. On the right hand side top, we are able to see that the wear plates has been damaged due to axial thrust movement, and at the bottom we see that the shaft is broken due to jamming of the compression. Now we will be talking about the rotary vane compressor. Rotary vane compressors are actually rotary compressor, but instead of a screw, here we are using a spring loaded. These are a spring loaded vanes. So we are using a spring loaded vanes. They are rotating inside a cavity or housing. Air or gas is compressed between the vane and in casing and is then pushed out at the different stop. So you can see these two are the front view, and this is the side view of the compression. So what happens that you see all these vanes are loaded with a spring. They can go, a spring pushes them out. So when the vane which is here on the right, on here, the vane comes out here because this rotor center is not matching with the casing center, it is off center. So the vane comes out, the air is coming or gas is coming from here, and it is now getting pushed on right hand side, slowly coming down. When it is coming down, you see the distance between the rotor and casing is reducing, so the vanes are going inside, pressure is increasing, and the air is forced out finally. So here this is the valve to control the flow of the air. This is in the side view here we can see the bearings and both the ends and the couplings. So what happens, as I explained you, that rotor is turning, vanes are coming out, and they are pushing it outside the rotor. Now when the incoming air enters the air end, when the pressure activator air end valve and which is regulating piston is opening, the air is drawn into the cylinder by rotating vanes which enclose space hermetically as they course through the compression area. The air is compressed as the volume between the vanes are reduced due to the eccentricity of the cylinder valve and the rotor. After maximum compression, the air exits through the outlet. In compressor, the intensive injection of coolant reduces the overall temperature of the compressor cycle and ensures proper lubrication. The injected coolant also functions as an active sealant to keep the vanes air tight. Here a drawing is shown. You can see this drawing in leisure. Each and every component is shown here. Now how to evaluate the normal operation. To evaluate normal operation and establish a baseline, it is necessary to record atmospheric pressure, gas composition entering the compressor, inlet flange, change in gas composition will change the gas density and then the discharge pressure. Gas pressure and temperature at the inlet of the flange of the compressor, gas pressure and temperature at the discharge flange of the compressor, cooling fluid inlet and discharge temperature. The actual inlet pressure and temperatures are often affected by clogged filter, mist pads or faulty process control. Similarly, actual discharge pressure and temperature can be affected by clogged discharge check valves, after coolers or separator vessels. Let us see some of the causes for the failure of the rotary vane compressors. Lubrication, lack of lubrication may cause bearing failure, dirt or foreign particle at the inlet and discharge of the compressor. This happens due to blocked or damaged filter. Discharge pressure. The single stage sliding vane compressor operates in some cases up to maximum of 60 psi, but it generally between 20 to 25 psi. High compression ratios are produced at higher altitude for the same discharge pressure, causing higher temperature operation. This must be avoided. Ambient temperature. For every degree of increase of air inlet temperature, there will be a corresponding increase of discharge temperature, causing the temperature of internal components to operate at higher temperature and their life will be reduced. Inlet pressure. The single stage compressor can operate at slight inlet vacuum of 8 inches of water maximum. A vacuum indicator is normally installed at the compressor inlet plate that indicates excessive vacuum, and there normally a alarm or lead signal comes at 15 inches of water column. If inlet vacuum is excessive, the compressor inlet temperature will rise, reducing the life of the blades. Discharge temperature. It is recommended that discharge air temperature probe be cleaned periodically every 6 months from buildup or carbon deposit and material. The deposit will insulate probe and will not change the actual discharge temperature. Now we will be talking about lobe compressor, which is also called root blower. This has got two kidney bean shaped impeller used to trap and transfer the gases. As you see on the right hand side, there are two impellers which are rotating opposite direction. The two impellers, they are rotating up opposite direction. They are mounted parallel to the shaft, and then it sucks the gas and discharge it through the discharge port. Compressed, the lobe do not touch each other. There is a few thousand of an inch clearance exists between the casing, between the lobes and the two shafts. And the lobes are being driven through the timing gear. This can produce low pressure and used as a blower. So if we see here, it contains actually a pair of, we call, involute profile, actually in the shape of 8. You see, this is forming a shape of 8, and that is the lobe or rotor. They are rotating in the oval space. This inside a space, housing is oval space and closed at ends by the side plate. One lobe is driving the other lobe through external power. Lobes are driven by pair of equal gear ratio, that is called timing gear. Both the lobes are rotates at the same speed but in opposite direction. So here you can see this is the lobe here and this lobe will rotate. This is the longitudinal base, and what you see on the right hand side is actually the front view. So you see the lobe, how the lobe rotates and then the gas is pressed. Timing gear is a must for the lobe compressors. Lobe compressor can be used as sometime as a vacuum pump also. So some special care for the lobe compressor is required. That is, all the shaft and body must be parallel to each other and the distance between them must be as prescribed in the manual. Any deviation may cause touching of the rotor either with body or rotor to rotor, which may cause body crack. There is a very critical requirement of changing the air filter the moment it is cleaned, so that you are able to provide a clear path to the air for the job design it is designed to do. Now let us talk about the maintenance. To ensure a full operating life from the compressor, preventive maintenance is absolutely essential. So you have to have operating log in that you should have discharge temperature, wire temperature, rotor thrust measurement, wire analysis, vibration analysis, filter differential pressure, bearing housing diameter check, cylinder diameter, bearing carrier, that is housing diameter, shaft general sheets, head plate surface, rotor dimension, length and width, parallel setting of shaft and housing with a specific gap is very critical. So here we will be seeing the assembly of a lobe compressor. So this is the housing of the lobe compressor. This housing we will be putting this side cover along with the bearing housing and tightening them with the screws. We will be inserting the two rotors, and then on the other side we will be putting again the bearing housing and securing them with the screw. Then we will be putting the locks here, and after that we will be putting the bearings on both the sides, and after that putting the bearing we will be boxing it up after putting bearing shields and other things. Now let us talk about the causes of lobe compressor failures. There may be air leakage, there may be pressure and flow problems, mainly due to the filter choking or component wear. There may be some loose parts, so that we need to adjust, tighten, and there may be misalignment. We have to correct the misalignment. It may be loose belt, bolt or pulley. There may be bad lobes, and then they may be striking with the bulb fuse, so that may make a lot of noise. We will have to change the lobes in that case. Faulty mounting, we need to correct it, the mounting. Extremely hot emissions, this may be because of the limited air inlet, worn plate and head gasket, poorly vented space, dirt accumulation inside the machine, and there may be valve issues related to quantity and quality. Here we are able to see the wear of the housing, wear of the rotor due to the contamination. Now it is very essential to maintain the operating log for the conditions. Every 4 hours we must record everything, which help us in maintenance. Also, maintenance and timely servicing of the machine is very important. Any deviation from normal operating condition has to be recognized, and immediate steps have to be taken to correct the problems. So thank you very much for your patience hearing. Now I will request you to like and subscribe my channel to get the information about the new videos which will be uploaded in the future. I have given the complete list of the video on YouTube along with their links so that you can view them. Thank you very much.